All right, lab 2, here we go. Name's Logan, CYB 503, lab 2, week 4. Huzzah. Okay, so we got to download this nice PDF and we got to make some recommendations based on logging, net flow data, and so forth. I'm kind of excited about this to talk about this is because this is what I've done at work for the past 3 weeks. Okay, so first thing, identify a highly recommended location to implement NetFlow exporter, either on the network diagram or as a report. Justify your recommendations by explaining logical reasoning behind it. Okay, so by definition, NetFlow, it's used to analyze and create a picture of a network traffic flow and volume. So, like all this subnet's really communicating over this port. So, I mean, this kind of ties into centralized. Actually, no, scrap that. So, net flow data. Here's what I would say. We want to get a picture of what this network is doing, and this network topology makes I don't know what I don't know who came up with this. This makes my head hurt. So, there's a couple questions that I have, and I know this video is going to go over 5 minutes, but because I've been thinking about this for the past day. So we see that we've got a layer 3 switch 1 and a layer 3 switch 2. So this is obviously like an access switch, and I'm going to assume this is like a core switch. So access and core, fun stuff. So we're going to want net flow data from multiple spots within this, because if you just choose one spot, you're going to miss a bunch of data. So we need north and south and east and west. So obviously we're going to want net flow data from the layer 3 switch, because we're going to want to see, what's communicating with, all these devices. And we're also going to want net flow data on this interface, because here we go, we've got a whole DMZ that's internal, and we're going to want it off this interface. And realistically, I would say we're going to want net flow data off this interface. That way, we'll start at the bottom. Switch 2, we can see what's talking to each other in the internal network. This interface right here off the core switch, we can see what's going in and out of the DMZ. We can see what's hitting our branch router. And then we're also going to want to see the traffic that's coming in and out of the network. That is vital. Okay, so that's 1. 2, identify a highly recommended place to generate logs for your seam. Identify a highly recommended place for full packet capture and justify it. Okay, so we're obviously going to want to log all of the hosts. That's obvious, just so we have visibility into what specific devices, what they're doing. We're not going to get really any valuable logs outside of the switches, because other than changes, okay, or maybe like an interface goes up, interface goes down, power supply. So you're going to get really system admin level alerts from the switches, and I mean, yeah, that's valuable. You definitely want it from your firewall too. You can see it goes back to NetFlow data, but you can see events that spawn from that, as well as firewall and the intrusion detection systems. Really, with the seam, I guess you're really concerned about malicious things and detecting them, as well as like syslog type stuff. All right. What was I on? 4. Find out if you need any new devices or need to twist the network topology in order to be able to detect the attack pattern anomalies more easy. I would rearrange this whole thing. So if we've got branch routers and branches and whatnot, this company's obviously got money. So we don't have any redundancy within this network, and we also don't know how big this is. They've got, well, We've got 800 devices just in here, so they need to have some sort of redundancy. What I would do, and we're going to open up a new paint. Oh man, hold on. Let's see here. Paint. There we go. We're going to briefly sketch this. So we're going to have 2 cores. And then we're going to also have 2 access switches. They're doing it with 1. They can definitely do it with 2. So AC, core, have, your generic redundancy. Oh, hold on. Let me, I learned this the other day. All right. We got a redundancy. Now let's see. We got to have some intrusion detection devices, as well as we got to address this whole DMZ thing. The one thing I don't like about this is actually traversing internally, and we don't want that. So we're gonna get sloppy with it. Okay, so we've got our main firewall. Should have redundancy here and high availability. This is where we need our DMZ. All right. And then depending, let's see here. All right, we're going to scratch this. We're going to put the IDS here. That way we can have visibility internally, and then we're going to also have an IDS here. Kind of hard to come up with network topology on the fly on Zoom. So now we've got IDS for north and south, as well as east and west. And then, yeah, we can just have our branch routers over here or something like that. That's what I would recommend. This looks rough to me. Present your design strategy. I hope I justified it. That's lab 2. Thank you.